With that, I'm going to go ahead and turn the show over to Ramasamy here. I'm turning on presenter mode for you. You should be able to come online now. A staff technical support engineer with Palo Alto Networks, Ramasamy is going to be able to go ahead and give today's presentation. Are you there, sir?
Yeah, hi. Thanks, Chris.
Charlie, but you're all set. All yours.
Yeah. Hi. Good morning and good afternoon to all. Welcome to day 3 session of GlobalProtect. My name is Ramasamy. I'm with Palo Alto for the last 3 years in the Prisma Access team. Let me share my screen. Just give me a minute.
Looks good.
Yeah, perfect. In today's session, we will be discussing about split tunnel, MultiVPN coexist, host information profile, and app log collection before winding up for the day. And we will continue tomorrow. We'll start the day with split tunnel. Let's see the use cases of split tunnel. When the customer doesn't want to send all those high bandwidth consuming traffic into the tunnel, like YouTube, Netflix, etc., latency sensitive traffic such as VoIP are sent outside the VPN tunnel, while all other traffic goes through the VPN for inspection and policy enforcement by the GlobalProtect gateway. The reason we send the latency sensitive traffic outside the VPN tunnel is because even a slight delay in voice calls can cause choppy audio or video, making the communication very difficult. Customers do not want to send any other traffic other than the private apps over the tunnel. What we mean by private apps are the applications hosted in your data center, and the internet traffic will go directly over the physical adapter. Non-Prisma Access customers are not yet ready to make additional investment, example, in terms of capacity, bandwidth, etc., required to tunnel all the traffic into the tunnel. Required to tunnel all the traffic. When you have for example, when you have 2,000 users, but you don't have the hardware capacity or bandwidth to accommodate all the traffics for all the users, in that case, you can just split tunnel the traffic, send all the internet traffic over the internet, and then keep the private applications over the tunnel. Split tunnel can be configured based on a couple of options. Example, access routes, domain name, applications, and HTTPS video streaming applications. The split tunnel rules are applied in the following order as shown in the diagram. Applications that are excluded based on application process name, applications that are included based on application process name, domain name that are excluded, domain names that are included, and last but not the least, access route. The point to note here is that if the same exclude and include rules are defined, exclude rule will take precedence over an include rule. We have a screenshot of a split tunnel configurations from the tunnel settings where you can see here. I'm not sure if you can see my mouse. I'm just hovering my mouse over here. The application which you can configure to exclude it, and then we have a domain name, and then the routes which can be configured over here. Enhanced split tunneling. For better understanding, think of an EDL where external list is hosted by Palo Alto instead of configuring the destination IP addresses and subnets URL directly on the security policy. In the same way, for split tunnel, the config will be hosted locally in your environment. So instead of the need to make changes to split tunnel config in the SCM or Panorama every time, and push the config to the firewall, you can manage the list of domains, access route, applications via the split tunnel configuration file hosted locally in your environment. This allows you to modify the split tunnel settings without having to modify the configurations on the GlobalProtect gateway, and you don't need to push anything to the gateway. We need to sign the configuration file and add the encoder digest to the configuration. The important point to note here is that the content in the file must not be terminated with the null character. Host the file on the web server that your GlobalProtect can reach. In this example, we have it over here. And then enable mutual TLS authentication on the server hosting the split tunnel configuration file to secure it. The public key is pushed from the split tunnel. The public key is pushed from the portal. And then the split tunnel configuration URL is pushed from the gateway to the endpoint. The endpoint needs the certificate to authenticate the web server to download the split tunnel configuration. The advantage of doing this is to increase the number of access routes and domain names in split tunnel configuration, apart from the config management point of view. This increases the include and exclude split tunnel access routes and domains drastically from 200 to 1000. We have a screenshot of a table which shows the split tunnel configuration limits when configured in the host on the gate, when the configuration is hosted on the gateway versus when it is hosted in a web server. The exclude route is increased from 200 to 1000 for the access routes. In domain, both include and exclude limits are increased from 200 to 1000, and there is no change in the limit for the application. It remains at 200 for both. This is an example of a split tunnel configuration file in an XML format. I've put a screenshot. You can see the access route, domain names, application path. And this one is after adding the encoder in the configuration file. Again, the point to note here is that the encode digest should be on the first line, and it must be on a single line, and the split tunnel configuration should start in the second line. Moving on to the wildcard support in app-based split tunnel. The main problem we are trying to address here is the path of the installation. The installed applications might change after an upgrade, and this breaks the split tunnel, resulting in an incident. This requires the split tunnel configuration to be manually updated by the administrator every time. From GlobalProtect 6.3.1, the path of endpoint application can be configured using a wildcard for the application-based split tunnel configuration. In this example over here on the right-hand side, we have configured the split tunnel. We have configured to split tunnel the traffic for Microsoft Teams. Before the wildcard support, our configuration will look like the original path, which you see over here. We have a full path. And then, but now after the wildcard support, the split, based on split, after the wildcard support for the applications based for split tunnel configuration, it will look like this. So instead of this full path, you can just give an asterisk over here. Now, even if the path changes, it's not going to impact or break the split tunnel configurations based on the application. Important things to know in split is Linux endpoints running GlobalProtect App 6.1 or later supports a split tunneling rules based on domain name access routes only. Split tunneling based on application is not supported on Linux endpoints. On Windows devices, UDP traffic is not supported for domain-based tunneling. It supports only TCP traffic. Again, for ICMP requests such as latency, jitter, trace routes are not supported in the domain-based split tunneling. Access routes based split tunneling is supported for all type of traffic, UDP, TCP, ICMP, etc., because it's just based on IP address and subnet. Domain name and application-based split tunneling are not supported in mobile devices. It supports only access route for IPv4 traffic. But you can use the per-app VPN on Android and iOS devices to achieve a the split tunnel-like functionality. Allow list and block list for Android define what apps can take the tunnel path. Include and exclude domain names for iOS. We have a screenshot over here. So this is for so this screenshot is VPN configuration via Intunes for Android devices. You can see here the app list for for allow and block. And this screenshot shows the per app VPN configuration via Intunes for iOS devices. So debugging the split tunneling issues on how to troubleshoot it. While troubleshooting split tunneling traffic, use the command route print to print the routing table in Windows to check whether the split tunnel config matches the routing path of the end host. In Mac, you can use netstat-r. The other things which you can do is perform a packet capture on all the adapters to see which to see whether the traffic is taking the physical or the virtual adapter. If the traffic is excluded from the tunnel, then it should flow via the physical adapter. In the packet capture, if you look into the MAC layer, so the layer 2, you will be able to see the source MAC address. With the help of the source MAC, you will be able to identify whether the traffic is flowing via the physical adapter or the virtual adapter. You can also make use of the GlobalProtect agent log files to analyze the agent side config and then the flow. Now this slide is to summarize the key takeaways for the split tunnel before we move on to the next topic. We saw application wildcard support from GlobalProtect version 6.3.1. Rule precedence order for split tunnel traffic. We talked about enhanced split tunnel for easy configuration management and to increase the access route and domain name entry limit. And then moving for Linux, the GlobalProtect, the application-based split tunnel is not supported. It supports only rule-based or the domain or access route. For Windows, domain-based split tunneling is supports only TCP traffic. UDP and ICMP are not supported. Access route-based split tunneling supports all type of traffic, TCP, UDP, ICMP. And in mobile devices, both Android and iOS does not support domain name or application-based split tunneling. You can make use of the per-app VPN to achieve the similar functionality. MultiVPN coexist. Some customers want to secure both internet and intranet traffic via GlobalProtect and also provide access to partner or vendors network through a third-party VPN where the user needs to access both at the same time. The internet and intranet and the third-party network. GlobalProtect can coexist with the third-party VPN application. For the third-party VPN to coexist with GlobalProtect, cross-exclusion is important. Basically, you cannot have overlapping subnets. The Prisma access should have exclusion for third-party VPN domains and the domains and subnets. Also, the third-party VPN should tunnel traffic only for certain subnets and applications. And it cannot be used as a full tunnel, which will create a conflict with GlobalProtect. Make sure the IP address of the third-party VPN gateway, when I mean the IP address, the peer IP address of the gateway, is excluded from the access route in the GlobalProtect gateway configuration. In the split tunneling options in app setting configuration, make sure it is set to network traffic only so that the DNS traffic is routed on the physical adapter. If you set it to S, then the DNS traffic, in addition to the network traffic, will be routed over the tunnel interface. Make sure the option resolve all FQDN using tunnel DNS server is unchecked so that the domain name is not resolved for all traffic using the tunnel interface. This will cause problem in resolving the domain names for the applications hosted behind your partner's network. With resolve all FQDN using tunnel DNS server set to no and third-party VPN mirror option disabled, DNS queries are sent to all adapters, your physical adapter, your GlobalProtect adapter, the virtual one, and then the third-party VPN virtual adapter. To avoid conflict, the third-party VPN network adapter name should be specified in the app settings under GlobalProtect portal settings, third-party VPN. So we have a screenshot of the third-party VPN. In this item, you need to configure the name of the adapter of your third-party VPN so that it doesn't create a conflict with GlobalProtect. With DNS sent to all adapters, either a physical adapter, we will look into which one will resolve which of which traffic. Either a physical adapter DNS resolver or a GlobalProtect pushed DNS server will resolve the DNS queries for your internet websites. The GlobalProtect tunnel DNS server will resolve the DNS queries for your intranet websites. And then the DNS queries for the vendor or the partner network will be resolved by the third-party VPN adapter on the endpoint. Even though the queries are sent to all the adapters. We have an example of a DNS query. All three interfaces, physical adapter, GlobalProtect, and the third-party VPN adapter has their own DNS servers configured respectively. You can see the IP addresses over here, and then a DNS query for a vendor's network, a resource like a jira.company.com will be sent to all three adapters. But only the DNS server tied to the third-party VPN adapter will be able to resolve it. Since it's an intranet, the other two DNS servers will not be able to resolve it. Troubleshooting the MultiVPN coexist. Check the routing table of an endpoint and identify what is expected traffic flow and what is unexpected traffic flow for the respective VPN. Perform a packet capture on all the interfaces to see the traffic flowing via which adapter. The key here to make it work is to make sure that you exclude each other's traffic, which means you don't have overlapping subnets for the one which you're accessing through GlobalProtect, and then the one which you're accessing through the third-party VPN. And make sure that the third-party VPN is not on full tunnel, and you exclude each other's subnet. Host information profile, or HIP. The host information profile is used to evaluate a security posture of an endpoint, and it is used to collect general information about hosts like OS version, whether the system has joined a specific domain membership, etc. It can also check for whether an antivirus is installed, firewall is installed, and is it running. It can also look for missing OS patches and so on. Once this information is collected, it can be used as a match conditions in your security policies. The config on what data needs to be collected by GlobalProtect is on the portal. GlobalProtect client connects to the portal and receives the configuration along with the refresh interval. The GlobalProtect client then connects to the gateway. After a successful connection to the gateway, the agent collects information about the host it is running on as defined on the portal. Once collected, the informations are submitted to the gateway. The gateways. So it will submit the information to all the gateways. The gateway will then match all the collected data against the configured HIP objects and profile. The HIP profiles later can be used as a matching conditions in a security policy. Note, periodically, the HIP reports are sent by the agents by default every 60 minutes to the gateway. And the refresh interval can be found in the GP logs. Before you implement the HIP, the best practices to follow, in case if you're not using HIP profiles on your security policies, we have seen some customers not using HIP profiles on their security policies. What you can do is you can also just create a HIP object without enforcing security policy to just have visibility into the state of your endpoint and the security posture. When creating a HIP profile, plan your configuration with consideration as we support a maximum of 64 HIP profiles. If a predefined HIP profile is available, make use of it instead of just duplicating it and creating another one. In majority of the use case, we have seen HIP is used for identifying managed and unmanaged endpoints, and endpoint security posture status identification. When we say status identification, it's like whether the firewall is installed and running, antivirus is updated, and so on. This is to avoid a user connecting a personal laptop to the network and start accessing all the internal resources. No one knows what is running inside a personal endpoint devices. And you don't want some unwanted visitors in your network. For identification of managed devices, you can use unique endpoint attributes such as whether a device has joined a specific domain, has a specific certificate, or a registry value, and so on. Once your HIP objects and profiles are finalized, you are good to configure them in the security policy. By default, End users are not given any information about security policy decisions that were made as a result of HIP-enabled security policy. However, you can enable HIP notification messages to display whether a particular HIP profile is matched or not matched. And when the next and what the user should do as a next step in case of a failure, assuming you're checking for whether a firewall is installed and running, and if that is not matched, the user will not be able to access it if the security policies are enforced with HIP profiles. In that case, you can send a notification to the end user asking to contact. You can send that the firewall is not installed or not running, and your access is blocked, and you can send a notification saying that contact service desk on so and so number. By default, GlobalProtect collects all endpoint application informations. However, you can optimize this by using exclude categories on the GlobalProtect portal app settings configurations. You can just, if you don't want to collect information about certain things, you can just exclude all those HIP profiles and objects into that. HIP issues are generally usually occur during GlobalProtect app endpoint posture evaluation. Did not match expected HIP objects or profile, causing the traffic coming from the GlobalProtect client to match a different security policy. In the starter logging services, you can use HIP logs to troubleshoot the issue. This will tell the administrator on which objects and profiles are matched. If a specific object or a profile is not matched, then you won't see any logs in the starter logging services. Or in the SCM, you can go to log viewer and switch to HIP logs. Coming on to the troubleshooting of HIP, it is important to identify at which point the HIP fails and when troubleshooting HIP related issues. The GlobalProtect client doesn't detect host information properly. You can have installed an endpoint firewall, but the GlobalProtect is not detecting it, or it does not propagate the report to the firewall or gateway. The gateway doesn't receive or accept the report. The report has reached the gateway, but it is not but it is not matching the HIP objects or profile properly. The profile or objects are matched, but it is not matching expected security policies with the HIP profile matching condition. You can find the actual HIP report sent to the gateway from the client in the GlobalProtect log files pan_gp_hrpt.xml. End users usually report the end results that they're not able to access it, even though if the issue happens on step 1, and all other stages will be unsuccessful. The notification here will help you to isolate, to find at which point it did fail the HIP match. Whether a firewall the failed or is it on an antivirus, so on. The key takeaways are in the host information profile. When we say that the GlobalProtect agent periodically collects the host information profile, is packed into a HIP report and securely transmitted to the GlobalProtect gateway. The gateway evaluates the HIP report against all HIP objects and profile. In the components, we have three components: HIP objects, HIP profile, and HIP match logs. In HIP objects, it defines a specific criteria for endpoint posture, like example, antivirus is installed, Windows Defender is enabled, OS is Windows 10. And in HIP profiles, it combines multiple HIP objects using a logical operator and or to create a comprehensive compliance requirement. Example, device has antivirus installed and device has encryption enabled. Coming on to the HIP match logs, it provides a record of whether an endpoint HIP report is matched a specific HIP profile. In troubleshooting, review the HIP logs, whether it has matched the HIP profiles correctly. You can do it in SLS again or in the log viewer in the SCM. Check the GlobalProtect agent logs, the pan-gpa.log or pan or the HIP the pan-gp-hip.log on the endpoint to confirm the HIP reports are being generated and sent. Verify the configuration on the firewall to ensure the criteria are correctly defined. GlobalProtect App Log collection. In the GlobalProtect, the GlobalProtect app can be configured to send troubleshooting and diagnostics logs from an end user's endpoint to Stata logging services for further analysis. When the end user reports an issue from the GlobalProtect app, the app can generate and send comprehensive reports to help you quickly identify the root cause of the remote end user issues. Or the GlobalProtect app can run an end-to-end diagnostics test to probe the state and performance of the network connections, and also perform a specific web application, the specific test on web applications from the remote end user's endpoint. This results in faster resolution of remote end user issues, enables increased productivity, and optimizes the user experience for the remote end user. The end user can directly send the logs to Stata logging services without the need for an administrator to involve or manually collecting the log, the GlobalProtect logs through email or through the cloud drive. Enable the ADEM GlobalProtect App Log collections for troubleshootings in the app settings in GlobalProtect. And in this screenshot, you can configure up to 10 sites that can, 10 websites to run diagnostic tests. The user can send reports directly by opening the GlobalProtect app and clicking on that three horizontal lines on the top right-hand side corner, and then click on report an issue. In that, the type of description of an issue along with the timestamp. When it comes to GlobalProtect issues, the exact date and time is very important. If the end user consent to run diagnostic tests, you can see a small checkbox over here to run to include the diagnostics logs on the GlobalProtect app. The troubleshooting log bundle and diagnostics logs are sent to Stata logging services from their endpoint, so that you can review them easily using the Explorer app on the hub. If the end user do not consent, if they don't check this box to run the diagnostic test and to include the diagnostics logs, and troubleshooting logs on the GlobalProtect app. Only troubleshooting reports without the troubleshooting log bundles are sent to the starter logging services from their endpoints for further analysis. Once you log in into the starter logging services instance and click on Explore app or go to the log viewer section in SCM, you can choose GlobalProtect app troubleshooting. You can see over here from the drop down. You can then analyze various fields under portal, gateway, network, app health, endpoint, state, etc. You just need to pick the correct the diagnostics and troubleshooting logs for a specific user. Again, a screenshot where it shows for the diagnostics log, the logs which we ran. For the server www.salesforce.com, we can see the latency, the in latencies, jitter, packet losses, TCP connect time, download speed, the trace route for Salesforce.